So hello guys, welcome to day 4 of habit tracking, coding every day until we reach expert. Currently my rating is 1399, which is one off from specialist. And in the next contest I'll reach specialist, and in the 2-3 months time span I'm aiming for expert. Until then I will be solving. Till then I think I'm solving every day like 5 to 6 questions every day, and on the weekends I try to solve around 10 to 11 questions of 1200 to 1400 difficulty. Okay, so yesterday I was not able to upload, but I did solve some few questions. So let's take a look at them. So this is Alice, Bob, and Candies. Now this question is very simple. Basically, let's say uh, there is an array. This is an array, right? And we have two people, Alice and Bob. Now there are candies spread in an array, right? For example, there are three candies here, one candy here. Let's say four candies here, one candy here, six candies here, and five candies here. Okay, okay, it's confusing maybe. So let's go with 3, 1, 4, 1, 6, 5. This was the array. Okay, now the question says that Alice goes first. Okay, now Alice goes first, which means array Alice will start eating from left to right. Okay, and Bob will start eating from right to left. Now what we have to do is whenever a player wins, when the current player is not able to eat more candies than the previous player. For example, Alice goes first. Okay, Alice Bob. Now Alice eats three candies in his first basically hunger spree. So now this is gone. Okay, this candy is gone. So okay, we move ahead and we say we come to Bob. Now Bob, see here. Okay, now Alice ate three candies. Now I have to eat more candies than uh, just enough more candies than Alice. So for example, Bob have a few choices, like Bob can eat this candies, Bob can eat these, Bob can eat this, and all of them together. Or what he can do is he can just eat this last candy. So then Bob will have five candies. Now this condition also holds right. Like Bob ate five candies, which is more than Alice, the amount of candies Alice ate, and we come to our next iteration. Now comes Alice's turn. Now Alice will see, okay, uh, Bob ate five candies in his last turn. So now I have to eat more than five candies, right? Alice's turn. So he eats one candy, which is okay. I have just ate one candy, which is not more than five. He will eat four, which is five. He will need to eat one more candy. So he will eat this one more candy. Now, what Alice has eaten? Six candies. Okay. And all of these candies are gone. Now come the turn of Bob. Now Bob will eat till he ate more than uh, just enough more candy than Alice. So Bob will eat six candies, and we will exhaust our array. So now we have to output the number of candies Alice and Bob ate and the number of moves made. For example, Alice made how many moves? Okay, Alice made he ate three candies, so he made one move first. Then come Bob. Now Bob made one move by eating the last candy. Right. Now Alice eats three more candies. Basically, this candy, and this candy. Right. So the like he eats total amount of six candies. So in one turn. Right. So turn will count as one only. Now comes Bob. Bob ate one more candy here. So it's one more move. So total is four. And the total amount of candies that they ate is he ate nine and he ate 11 candies. That is the output that you have to get. The basic implementation question, pretty easy. So I solved it when, yeah. So here you can see I'm just iterating over the index from the start and to the end. Okay, if this is just a flag to indicate which player term it is. Now I'm just iterating over the array from the back till it is greater than the amount of candies Alice ate. It is just greater than, and I'm adding it to my current, and I'm making the move plus plus basically to account for the number of moves made. Now if current is less than equal to previous year, right, then we just output the moves and A and B, because this means if we have like exhausted this array, right, we have exhausted this array and still we haven't like found the total amount of candy to surpass our previous opponent. So we just need to output the array and same goes here. So pretty straightforward question, I think. Not much thinking. Now other question came Q. Okay, so very this is also a very easy question. So it says that there is a queue, right? And you need to print how many people are satisfied. For example, the question states there is a queue. Okay, now there are people standing in the queue, and these people will have an array. It will have wait time, and it will have the amount. Sorry, it won't have wait time. It will have the time taken for them to complete their order or to serve them. For example, 15 2 1 5 3. Okay, now this is the basically the wait. This is the time they like. Let's say to prepare the order. Okay, now for each like we have to tell how many persons are dissatisfied. Now person becomes dissatisfied when he has to wait more than he when he has to wait more than the time taken to serve their order. Basically, let's say if this person, fourth person here, has to wait 6 minutes of time. So and he his order just take 5 minutes of time. So he will be dissatisfied. So this was a very easy one. So basically, if we have to for example, you can see we just need to sort it according to the time taken to serve their orders, right? Because a person has to wait if he has to wait 1 unit of time, then he should be placed first, right? Because the more you place him at the end, right, the more dissatisfied he becomes. Like, it's like tell you, is it better to place 15% at the first or the last? Of course, it is better to place him at the last, right? Because he can wait 15 seconds, and in that 15 seconds, we can serve these orders also. So he won't become dissatisfied, and we will also fulfill our condition. If we were to place him 15 here, right now, this is a very big number, and it would become a wait time for the other queue members. So we don't want that. So basically, we need to sort it 1, 2, 3, 5, 15. Now, here is the catch. The catch is, uh, for example, you okay, see total wait time. Okay, now for this total wait time is 0, and the first person comes here and he says the total wait time is less than the current time taken, right? So he will just say, okay, I'm satisfied, and the total wait time will become 1 because this person is served, right? Now we come to the next person, and he says, okay, if 2 is greater than 1, now he will become satisfied, and this will also add into the uh, our total wait time. Now it will become 3. Now he says, okay, so this is equal to, he will also become satisfied, he will come to 6. Now you see the thing here is this uh this man, okay, this man is dissatisfied even in the most optimized condition also, right? This is the most optimized condition or most ideal condition one could have to reduce the number of dissatisfied people. Now, if this person is dissatisfied, which means he won't be satisfied in any of the conditions, because if I were to place him at the first, it would mean that I am making I'm making 1 and 2 dissatisfied, right? And also 3. For basically for saving one customer satisfaction, we are sacrificing the satisfaction of these 3 customers, which we don't want. So in this, you see in this array, when we arrange them in the most ideal condition, if a person becomes dissatisfied, he won't become satisfied either way. So what we can do is we can reduce this total wait time, right? Like if we were to place it here and we were to say, then the total wait time will increase from 6 to 11, because this will get because this his serving time will get added to the total wait time, right? And we don't want that. So what we can do is we can just simply say, okay, you are a very rude person, you won't become satisfied either ways, so you just go back at the end of the queue because you will remain dissatisfied either ways. Now comes 15, right? 15, okay, this. So he says 15, 6 is less than 15. So he becomes satisfied and this is less. So answer is 4. That is the catch here. If a person is dissatisfied in the ideal condition, you just need to uh, you just need to place them at the end and don't count their basically serving time, the total wait time. That is the catch here. Okay, let's see the solution. Okay, so I missed that condition in my first solution. That's why I got a wrong answer. I was adding it to like I was adding it either ways, right? See here you can see I'm adding it either ways. If a person is dissatisfied, we can just send him back to the line, right? So here now this is the correct condition. We just need to place that wait time into a simple else if block here. Else wait plus is equal. If a person is satisfied, if a person is dissatisfied, answer minus minus. We just need to reduce the total number of satisfied persons and just say else if he's satisfied, then we need to serve him and we need to increase our wait time. Simple as that. Now comes near array. What was this question? Oh yeah, it was a very good question. Not very good, but okay, mediocre question. Okay. So this was uh, okay. Uh, so I forgot. So, yeah. Okay. So the question is, you are given an array A, okay, and you have to make it increasing array, non-decreasing. Okay. Sort it, and what you can do is you can swap I and J. But the condition is if and only if GCD of A of I and A of J is equal to minimum element. That is the catch. I hope I'm right. GCD is equal to C. You can choose two different array indices, okay, and is equal to the minimum element of the whole array. You can swap AI and AJ, okay, and you have to make it non-decreasing. Okay, let's see one example. Uh, 4, 6, 6, 2, 9, 7, 5, 2, 2, 4. Okay, now uh, now in this array, okay, now you have to see one thing. Here we are talking about minimum element. Now we aren't performing any operation which changes the minimum element. So what we can say is the minimum element will remain same. Okay, and we just need to then calculate which indices have and GCD same, right? So if we can get the minimum element, we can maybe do something on that. So the minimum element here is 2. Okay, then what we can do is we can swap it, right? We swap it with uh, this 6. Okay, we swap it with this 6. Now it becomes 4, 3, 2, 6, 6, 9. Okay, then we swap this 2 and this 4. It becomes 2, 3, 4, 6, 6, 9. This is sorted, right? Simple. Now you see here. Here the answer is no. We can't sort this array. We can't sort this array. Okay, because the minimum element is 2. Now, whatever the elements of the swap, the GCD should be 2. And you can see you want this 2 should 2 come at first place here. And you can see GCD of 7 and 2 is equals to 1 because they are prime. Okay, so we can't swap these. So the answer is no. Now let's see the logic behind it. So the thing here is for two elements AI and AJ. Okay, now if you look closely, okay, the GCD is equal to the minimum element. Okay, and like for example if you take for example a minimum element in array, for example a minimum element is let's say 2, okay, and the element we have to swap is 4 and 6. We can swap them because the GCD is 2, right? And if we were to take this we were to change these elements and we were to take let's say GCD with 4 and 2, it would be 2 again, and we were to take GCD with 6 and 2, it will be 2 again. right? Do you see a pattern here? Do you see a pattern? Because let's do one more. 6 8 is equals to 2, mm, and then 6 2 is equals to 2, and 8 2 is equals to 2. So this means if we take our GCD with a minimum element, it will be same as the GCD if it was an answer. See, this is a perfect pair. Like this is a answer. This pair we can swap. And if we were to like take the GCD with the minimum element of these two, then it would also work, right? And 4 6 2. If this is the array and you need to swap them, you can easily swap them. You can take 6 as an intermediary node, like okay, you can take that as a middle node and you can swap them. For example, first you swap 6 and 2. So 2 will come here, 6 will come here. Then you swap 4 and 6. Oh, sorry, 4 and 2. 2 will come here, 4 and 2. So this is sorted, right? So that's the main crux of this question. You need to check for any element that is out of position. If it's GCD, let me show you the solution also. If its GCD is not equal to mini, okay, we say if its GCD, if its GCD is not equal to mini, then no answer. That is the main solution of this question. Like for example, if we were to take 4 and 6, this is the okay pair, and if we were to take in GCD this 4 and 2, it is also okay, and 6 and 2, it is also okay. So our theory stands. The GCD with the minimum element, basically the GCD with A of I and minimum should be equal to mini, and GCD with A of J and mini should be equal to mini. That is the main thing. And if it is not equal, then there is no answer. We can't solve them. So you see, I just uh, sort this into a temporary array. Then I check if any array or any element is out of position, then where it's supposed to be. Then we just need to check GCD of that misplaced element. GCD of those misplaced element, basically the element which you need to swap, if it is not equal to mini, right? And if it is not equal to mini, then we just output no and we just return. So it's a very intuitive question. You have to observe closely. Now this was a social distance question. Oh yeah, okay. So basically, it says the question is you have to place the most amounts of ones which you can place, and also keeping in mind that for every one there should be k zeros before it and after it. For example, this one, there is k is this one, so it has 1 0 and 1 0, like this at least one. If it is more than k, then it's fine, but at least k0 should hold before that and after that. So if we were to place a 1 here, we can't place that because this condition will break. Alright, and if we were to place 1 here, it would be bug fine. Let's see, for this one we have uh, basically 1 0 after that, right? And when we place 1 here, we will have 1 0 after that and 1 0 before that. Same for this one. So we can have, the answer is 1. We can place one more 1 here. Okay, now this was just a construction algorithm. Basically you have to implement it and construct the answer. So so here what I did is uh, I created a suffix array just to get the last position of the, like, if I can get the position of the previous one where I found, because I'm iterating from left to right, but to find the position of the one which is after it, I need a suffix array. So that's why I've taken suffix array, right? So I did nothing. I just the last in my into max, and then if I see one, I just update this suffix I with I that I see one here. Else it will be I plus one. And when we come here, we see if f of I equal to one, previous equal to I, continue. Okay, because we can't place one over a one. And if previous equal to minus one, which means it is the first zero which we encounter. So that means we need to check the condition. Like if previous equal to minus 1, which means it's the first zero which we have encountered, right? Like at the index 0, this is the at the index 0 there is a 0. Then what we need to do? We need to check if suffix of I, like at this array, what is the upcoming position of the 1, right? So this returns the upcoming position of the nearest one to it on the right side. And we need to subtract the current index and we need to subtract 1 to get the total number of zeros between them. And we say, okay, if it is greater than equal to 0, all well and good, this can become 1 and previous equal to I because now this index has 1, right? Else we can, what we can do is we can get L, we can get R, and using a very simple formula, R minus L minus 1, we can just do this. If L is less than K, right? See, L minus R minus 1, L, sorry, R minus L minus 1. Using this formula, you can get all the elements in the middle, right? For example, 3, for example, 4 minus 1, which gives 3, and minus 1 can give away how many elements are between 1 and 4? There are 2 elements. So 4 minus 1 will give 2. So that's what we are getting. Now we check if L is less than K or R is less than K. Like if there are less zeros here and less zeros on the right, if we were to place a 1 here, then we just continue. Else we place a 1 here and the previous will become I because this is the place where I found 1 here because I'm placing it. And I just count the number of ones and subtract it from the original ones that we have. If no ones were added, then this would become 0. If one more one was added, the answer would be 1, and just like that. Okay, I think that will be all for today. Let's meet tomorrow. Thank you guys. Thank you.